So the topic I'm going to speak is the self-organizing map-based method for finding plastic patches on the sea. And I am from University of Calledda. So I am going to speak about the plastic waste on the ocean, and then we will go that how do we extract data from the satellite, and then we will see a technique used to detect the pattern of plastic in the open sea. We will describe a method which will help to for in future and help us in this research to identify the density and of the plastic. And then we will discuss the result and discussion. So the main reason is the plastic has been accumulated in the marine, and it has been the very basic and major problem for the marine life. And the ocean currents take it into the open waters, and in there it creates a lot of problem. So the traditional method that has been using to detect it has been very costly, and it has very limited exposure. Like it is mostly not available in open oceans. And so right now we are implementing a remote sensing based satellite imaging method through which we are trying to extract the data, and then we are applying some multispectral satellite images. After getting it, we are using high resolution satellite images to find plastic debris patches in the open sea. So we are collecting data from the Sentinel-2, which is a wide-swath multispectral imaging mission launched in 2015. It has 13 spectral bands of 3 different widths of different resolution. One out of which 4 are of 10 meter, 6 are 20 meter, and 3 are 60 meter of resolution. And this was the program is taken by the European Copernicus. And here the website if someone wants to visit it. So the coverage area of the Sentinel-2 is basically taken by the two satellites, Sentinel-2A and Sentinel-2B, launched separately, and they approximately cover 290 kilometers in total. And it covers all the continental lands, including the inland water from 82° north to 56° south, all the coastal waters up to at least 20 kilometers from the shore, all land water greater than 100 kilometers square, and all EU inlands, all Mediterranean Sea, and all closed water like the Caspian Sea, etc. So to access the Sentinel-2 data, we have to access through this website, and then we reached to the website, we can go to the Open Hub, and through Open Hub, here we can search select the area and the satellite through which we want to collect the data. And the data we collect is normally in the SAFE form, which is the short of standard archive format for Europe, which now we can also get JPEG images in that. And these images have multispectral images that we extract from this data. So after getting data, what do? We apply self-organizing map an algorithm on it. And this is an example. Here you can see like we have 3 different clusters, and we made 8x8 grid. And this cluster has, on the basis of Euclidean distance, they have trained to search that where the cluster appeared. So the flowchart of the method we got here is we collected the data from the image. This is an example of that image of the Honduras River. And then we have made 13 different images of the same image in the pixel. And we took the pixel out of it. We made the pattern of those images. And then we have clustered them using a self-organizing map on a subset of a pixel. And after that, we call the same SOM on the other images. And after that, we labeled in the form that whether they are plastic or not by 1 and 0. And at the end, we create different cluster with the help of images to get the output to identify whether plastic is there or not, and what is the density of the plastic or concentration of the plastic available in that area. So as I have just mentioned here, that we have the Sentinel-2 Copernicus Hub The data we collected is from the June 2021, and from the 13 different wavelengths that varies from 480 to 200, 2200 nanometer, out of which we used 7 of them, not all of them. And we input 7 inputs, and then we got about 10 by 10 of 100 output clusters. And out of them, we have 200 number of epochs of it. And the rule we applied to collect and to get the data or to implement it, the winner takes all rule. For training on the basis of self-organization map, we have a data set of 10,980 by 10,980 pixels, total of 120,560,400 patterns which were created. We shorted for the training set for the to avoid the computational problems. We have taken to short it up to 1,000 pitches, and so we collected at the end 120,560 patterns that we got out of it. So here we can see the actual the Hundreds River, and this is the original image. And here you can see the image that we have the clusters that we got at the end of this of the SOM training and the cluster that we got. So here, this is the reference image that we have here. And here we can see this is the same image, but all the picture shows is the mainland and the clouds mostly, and it does not show any of the plastic in this image. If we go into the next one, here, since there isn't any, in this area, there isn't any land or any cloud here. So there is a potential that there could be plastic debris available in this area. And it shows that there must be some foreign object, not water, not any other thing, not cloud, anything else. And here again, we see the same thing. Again, there is no evidence of anything else, any other formation. So it is also a candidate for the plastic debris in the middle of the ocean. Here we see that they are both available here, and in the image we see the land pixels here and the sea pixel as well. So which does not correspond any of plastic debris in this picture. Here we can see that this is the river we can see, and this is all the plastic available in the which is coming out of the river. And this is another patch of the river we can see here. And this is the lean river through which, out of which all the plastic has been accumulated in the open sea and going out of the coast. Here, this is the river which we can see, the Ulva River. And but we observe here in this formation, and this is another river here. And we can see all this formation of the plastic, which is not connected to anything and must be a foreign object or a plastic and accumulation of such thing that is causing problems for the coastal areas. So in the conclusion, I would say this is the preliminary work that we have done to identify ocean plastic debris patches from the multispectral satellite images. And for this purpose, we use unsupervised learning to cluster pixel satellite images in order to define homogeneous group among which to subsequently identify associated in the presence of plastic. In principle, one significant number of cluster has been typed, then we can extend the same result to analyze the other geographical areas. And here I rest my presentation, and thank you all for listening.